This is my model. I am Jella Tejas. So the model that I choose is state machine model. So state machine model introduction. A state machine is a model used to represent the behavior of a system, which can be a software system, an electronic system, or any type of system. It is composed of a set of states, each representing a specific condition or mode of system, and a set of transitions between those states that determine how the system behaves. So it explains here that state machines are commonly used in the design and implementation of software systems, particularly in embedded systems, where they can help manage complex logic and control the behavior of a system in response to various events and inputs. So, they can also be implemented using various programming languages and tools. And they are widely used in real-time systems, control systems, and user interface design. So next, we have here types of state machine. Number one is finite state machine, or FSM. This one, a finite state machine or FSM, is a specific type of state machine that has a finite number of states and transitions between them. In an FSM, or a finite state machine, the system is always in one of a finite set of states, and the transitions between states are triggered by specific events or inputs. So, FSMs are widely used in the design on and implementation of hardware systems, such as digital circuits and microcontrollers, as well as in software systems, particularly in areas such as natural language processing and game development. So, we have here next Mealy machine. In a Mealy machine, the output of the machine depends not only on the current state but also on the input. The output is generated as soon as a transition occurs. The state transition table includes both input and output values. So the output is produced as the machine moves from one state to another. So this type of state machine is useful in application where the output depends on the current input as well as the current state. One example is a vending machine that displays the product information as soon as the user selects a particular item. So the third one is Moore machine. In a Moore machine, the output depends only on the current state and not on the input. The output is generated only when the machine enters a new state and not during the transition. The state being transition table only includes input values, and the output is associated with each state. So, this type of state machine is useful in application where the output depends only on the current state. One example is a traffic light system where the color of the light changes based on the current state. For the fourth one is we have here the hierarchical state machine. This one consists of multiple state machines where each machine represents a subsystem or module of the overall system. Each subsystem has its own set of states and transitions and can have its own substate machines. So this type of state machine is useful in modeling complex systems that can be broken down into smaller subsystems. One example is an airplane control system where each subsystem, such as the engine, navigation, and landing gear, has its own set of states and transitions. And the fifth and the last types of state machine is the Harrell state chart. This one is a type of which is the number 4, that includes the concept of concurrency. It is used to model systems that with multiple parallel processes or events that can occur simultaneously. In a Harrell state chart, each state can have multiple concurrent substates, and each substate can have its own set of transition and events. And this type of state machine is useful in modeling complex systems with multiple parallel processes or events, such as real-time control systems. So next, we have here state machine usage in embedded system. It says here, state machines are very commonly used in embedded system to model and control the behavior of the system. In embedded system, the state machine is often used to represent the system's control logic or user interface. So next, we have here some examples of how state machines are used in embedded systems. So number 1, we have here control logic. In many embedded systems, the control logic is modeled using a state machine. The control logic can be used to manage the system's power modes, handle interrupts, and perform other critical system functions. So for example, a state machine can be used to control the power management of a battery-operated device, such as mobile phone or a smartwatch. The state machine can manage device power consumption by transitioning between different power modes based on the device activity level and battery level. So next one, we have here user interface. Another common use of state machines in embedded systems is to model the user interface. The user interface can be modeled as a state machine with states representing different screens, menus, or modes of operation. So we have also here examples. A state machine can be used to control the display of digital thermometer with states representing the different temperature ranges and transitions between the states representing the changes in the temperature. So the next one, we have here sensor data acquisition. In many embedded systems, state machines are used to acquire and process data from sensors. The state machine can be used to control the data acquisition, process, and ensure that the data is properly processed and stored. So we have also example for this one. A state machine can be used to acquire and process data from a temperature sensor, with states representing the different stages of the data acquisition process, such as data collection, filtering, and storage. So that's all for the examples of how state machines are used in embedded systems. So, in summary, state machines are a powerful tool for modeling and controlling complex systems, especially in embedded systems. They provide a structured approach to designing and implementing control logic, which can improve system reliability, predictability, and testability. State machines require careful planning and design, and can be difficult to modify or troubleshoot. Despite the challenges, state machines are essential in managing system complexity and controlling system behavior in modern embedded system design and implementation. And that's all for my presentation about state machine. I am Jaila Tayabas from BSCPE 4A. Thank you.